Hello everyone, how are you? Welcome to CP Addict. Seriously, how are you? I want to know about your health. Let us know in the comment box. Will you or you won't? Okay, then let us proceed with the video for which I am here for. Otherwise, the CP Addict manager will fire me. So in this video, we are going to look at the problem A and problem B from today's Codeforces round 673. It was a division 2 round. Where the fuck is our DJ? Hey DJ, hit the intro music, you stupid guy. All copy paste. What it says is, we have some hero guy, BT hero. Don't know who the hell he is. They say he is a powerful magician and he has got n piles of candies. The ith pile contains AI candies. And that magic guy BT hero can perform few spells. What he can do is, he can pick two piles from index ij such that I is not equal to j. Then he can copy the candies present at ith pile and paste it on the jth file. After his bloody cast, the candies on jth pile would be aj plus ai. And we want to find out the maximum number of cuts that BT hero guy can perform. And there is one more thing. If some pile contains strictly more than k candies, that guy cannot perform his magic anymore. He loses all of his powers. Let's see how we can solve the problem. And there is one important information there, that is, initially all AIs are less than equal to k. Okay, let's move to the Microsoft whiteboard. Although it is not a whiteboard, it is a blackboard. So we have n piles. And what can BT hero? That bloody BT hero guy, he can pick two indexes such that I is not equal to j, and he can pick up the candies from ith pile and add to the jth pile. And after aj would be equal to aj plus ai, and he can only cast a spell when after performing the spells aj is less than equal to k. So as we want to find out the maximum number of spells that BT hero guy can perform, we should be adding the minimum number of candies we can in one spell, such that BT hero guy can perform as many spells. So why don't we pick the pile which is containing the least number of candies and use that for his spells. Like whenever that guy wants to perform his spell, he would be picking these number of candies from that pile and pasting on some other file. So what we will be doing, first we will sort the array, then we will go from right to left, that is from the pile containing the largest number of candies to the pile containing least number of candies. And for each of those piles, suppose the candies present at that index is aj, we will find out the difference of k minus aj. Suppose this difference is difference itself. Then we'll try to find out using this range how many times we can perform our spell using a0 of piles. So we will simply do divide by a of 0. It will tell us for that particular pile present as index j how many casts we can perform on that pile. We will do that for each of the indexes from n minus 1 to 1. We cannot perform his magic if we are at the same index. That's all for the question. Let's see the code now. Yes, first I have taken the input, I have sorted the array, then I'm going from right to left. I'm finding out the difference, which is k minus array. I am dividing it by the pile which is containing the least number of candies. Then I'm printing the answer. That's all. So why don't we move to the problem B? Okay, I'm moving to the problem B. Wait, hang on. The problem B is called two arrays. Okay, two arrays. So there is one guy, Red Dreamer, has an array consisting n non-negative integers. This non-negative might be useful, and an unlucky integer t, just like me. Let's denote the misfortune of array B having length n is equal to fb. Misfortune is equal to number of pairs ij such that I is not equal to j or j is greater than I, and the sum of elements present at those two indexes is equal to t. So number of such pairs is equal to the misfortune of that array. What we want to do, we want to distribute the elements of our array A into two sets. We will color them using white and black. The elements which are colored with white would be present in one set, and the elements which are colored with black would be present in the other set. We will then find out the misfortune of those two sets and then add up the sum, which is fc plus fd. We want to minimize this useless value. Let's see what we can do to solve this problem. So it simply means for one array, let's say for an array, it should not contain, or it should contain, the least number of pairs such that if we pick those two pairs, the sum of those two elements is equal to t. We must be minimizing this value. So if you see, what we can do here is, we have a value t. There are basically three cases. This is the region where all the elements are having value less than t. This is the region where all the elements are having value greater than t. And this is where the elements are having exactly t by 2 value. So if we put all the elements which are having greater than equal to t value in one set, let's say it is set number 1, that is, we color these elements with color 1, and all the elements which are containing value less than t, we will color them with 0, that is the white color. Yes, I am writing white using green color. So if we pick any two elements from this region, we are sure that the sum would be less than t, and if we pick any two elements from this region, the sum would be greater than t. So there is no way we can find any pair such that this condition would be satisfied. The only time this condition would be satisfying is when t is even and the value we are getting, array I, is equal to t by 2 exactly. Suppose t is equal to 6, then if we have a value 333, then these value would be making pairs such that their sum would be equal to 6. So for all the other elements, we have found a way such that they won't be used in the number of pairs such that the pairs which we want to minimize. But the values when t is equal to even and array of I is equal to t by 2, then we should be careful with these elements. So what we can do here, suppose we have x elements, or let's say count elements. We have count elements such that they are of this type. Then we will put count by 2 elements in set 1 and other count by 2 elements in set 2. And yes, if this is odd, suppose this is 7, then we will place 3 here and 4 here. Then we will see the number of such pairs would be minimized. It will contain 3 such pairs and it will be containing 3, 2, 1. It will be containing 6 pairs. Why we are distributing them in this way? Let's pick an example for 5 where count is equal to 5. The way we can distribute this is 0, 5, 1, 4, 2, 3, and yes, 3, 2 is not useful as we have already seen 2, 3. For these pairs, set 1 will be containing 0 such pairs, but set 2 would be containing 4 plus 3 plus 2 plus 1 pairs, which is equal to 10 if I am not wrong. And in this case, it will be containing 3 plus 2 plus 1, which is 6 pairs, and in this way it will be containing 1 plus 2 plus 1. So this is the least possible. This is the best way we can distribute these such numbers such that those pairs are minimized and our misfortune is also minimized just because of that unlucky number t. Let's see the code now. Yes, it is a small code. First I have calculated such numbers which are equal to t by 2 and also t is also even. I have stored their count in a variable count. Then I have taken count by 2 in x. I am seeing if the element is greater than t by 2, I am placing in set 1. If it is less than t by 2, I am placing in set 0. Otherwise it must be equal to t by 2. I'm checking if t is even and also the current element is t by 2. Then for the first half I'm placing them in set 0. For the next half, when x has become equal to 0, then I'm placing those elements in set 1. So they are distributed in 2 sets. And yes, else it means t is not even. Then we can place this area in any of the sets. And in the end I'm printing the array. That's all for this video. I hope you liked it. If you did, please like this video, press the like icon, not the icon, whatever it is, the icon, and share it with your friends, and press that fucking red button which has subscribe written on it. Why don't you subscribe, man? And yes, I'll be seeing you in the next video. Till then, have fun. Take care of your friends and siblings and family and teachers and students and the whole world. Sayonara.